So thanks a lot for dropping in for this session. I'm Sanat, part of Plaksha University's admissions and outreach team. As you might know, Plaksha is an upcoming liberal arts and sciences university in Mohali. Uh, the topic for today's conversation is workplaces in a data-driven economy, extremely contemporary, and we have with us perhaps the best people we could get, anyone could get to discuss this topic. I'll briefly introduce everyone and we'll kickstart the discussion. First, we have Professor Ravi Kothari. He's currently the head of Department of Computer Science at Ashoka University. He has been a chief scientist for IBM Research for over a decade and has considerable experience across research, academia, as well as industry. Then we have Mr. Hitesh Oberoi, who is currently the MD and CEO of InfoEdge India Limited. You would know a lot of companies that fall under this brand, which includes 99 Acres, Jeevan Sathi, Shiksha, and of course, Naukri.com. And finally, we have Mr. Sebastian Foucaud, who's currently the chief data officer at HRS Group, which is a German-based travel company. Most interestingly, he holds a PhD in astronomy and astrophysics from University of Aix-Marseille in France. And he also enjoys considerable expertise as well as experience in data across sectors. This session is meant for you. So please feel free to ask as many questions as you want, and I'll curate them throughout the discussion. So to kickstart, I'd go to Professor Kothari. Professor, there's a lot of confusion around the word data science. So maybe it will help if you can start with clarifying what the term really means and why is data science suddenly so important in today's workplaces. Professor, we can't hear you.
Yeah, thank you, Sanat, and welcome everyone. So there have been a couple of major shifts in recent years, and one of those is that our ability to instrument things has grown phenomenally. Right? So, for example, if you take a modern car, I mean, it is hugely instrumented. It can measure hundreds of variables, and in fact, it does measure hundreds of variables over time. If you look at a modern warehouse, a lot of the racks, a lot of the storage spaces are instrumented. They can gather information, about the amount of things on the rack automatically. So our ability to instrument has grown very significantly. You can have instrumented houses in which every single window can be instrumented. When it opens, it records it somewhere. So our ability to instrument things have changed, have increased substantially. And in parallel with that, our ability to process data has also increased very substantially. So when you bring both of these things together, the obvious question is, well, how do I use it to advantage? Can I get more business insights? So if I can instrument a car, can I understand how safe a driver you are? Rather than getting my car serviced every 3 months or every 6 months, some fixed thing, maybe a good driver needs to service his or her car at sparser intervals, and a more aggressive driver might need more immediate servicing or more frequent servicing. So this ability to instrument and this ability to process a lot of data generates, the obvious question, or prompts the obvious question, that can I use data for business insight? Can I use it to improve quality of life? And in reality, that's what data science is all about. Right? It's trying to use data, trying to gather data, trying to use data in order to improve quality of life, improve efficiency of businesses, and improve efficiency of service delivery in the government sector, and so on and so forth.
Thank you. So since you mentioned the potential of data in business, I'd like to move to Hitesh. In Hitesh, as I mentioned earlier, back in college, we used to say that your companies pretty much take care of all that humans could need, whether it's education, jobs, marriage, property, etc. So I'm sure you have seen a lot of transformations in the last few years, especially with respect to data and AI. Could you give us a glimpse of that?
Sure. So, we started more than a couple of decades ago. So at that time, the concept was very simple that, just like you see a lot of newspaper ads for jobs and matrimonials and education and real estate, why can't we move everything online, and make it searchable and make it accessible to everybody 24 by 7? And that was the original concept, and that's how we all started. And so, and that's where we stopped actually for a while. We said, okay, we made these listings available, these jobs available to everybody. We have 1 million jobs or 500,000 jobs in our database. We have so many resumes. So we were in some sense a database company, right? We had a database of jobs, a database of job seekers, and we sort of tried to match the two and said, okay, listen, why don't you just figure it out all by yourself? Similarly, in matrimonials, similarly in real estate, we had a database of houses available for sale or rent, and we had people on our platform who were looking to buy houses, and we said, okay, we'll connect you, and you figure it out all by yourself. And that's where we used to stop. I think the big shift in the last few years has been that we are beginning to understand that we can do a lot more. Every time somebody spends time on our platform, they leave in some ways a digital footprint of themselves on our platform, right? So we know, for example, earlier it was, listen, let people come and go, then they'll figure it out, right? Today it is, listen, okay, Sanat was on our platform a week ago. He looked at the following listings. We know he's looking to buy a property in Delhi. We know that his budget is 50 lakhs. We know that he uses a mobile phone and he's got an Android device, and he's normally active between 5 p.m. and 7 p.m. And he came last on Thursday, and he's not been to our site for the last 7 days. So we know so much more about you today. I mean, it's not as if we couldn't have captured this information earlier. It's just that we didn't have the tools, and we were not thinking like that. And we were not as sophisticated, in terms of the skill sets we had inside the company. And nor were we willing to invest so much into doing all this. But what we've understood over time is that if we start investing in all these areas today, and if we start capturing this information, we can use this information to massively, one, improve your user experience on our platform, right? So we can prompt you with the right ads at the right time. We can sort of send you the right notifications. We can engage you more. If you are dropping off, we know how to get you back, and so on and so forth. So in some ways, we are using the data to improve and enhance the experience for all our users, all our customers. We are also getting better at using data to match, to help you get to what you're looking for faster. Because as the database grows, if there are 60 million resumes in our database, and a company like, let's say Infosys wants to hire a Java developer in Bangalore, the search may throw up, 1 million or 500,000 or 200,000 matches. Now, nobody wants to go through 200,000 people. So we can then look at the history of Infosys on our platform, for example. What kind of people has Infosys hired in the past? What kind of institutes do they hire from? What are the salaries they pay? Which kind of people are successful at Infosys? And then narrow down the data set for them from 100,000 to 1,000, which is more processable for them, right? And all this can be done through smart algorithms which have been developed by data scientists over the years, learning and AI and so on and so forth. So all I'm saying is that, thanks to advances in data science, and thanks to the availability of such people who have these skill sets, and thanks to the fact that companies like ours are beginning to understand the strategic value of the data they're sitting on, we can now use the data at our disposal, and we're already doing it, like I said, in multiple ways. To one, of course, provide a business with more analysis, and help them, and in fact, in many cases, help them with predictions. This is what is likely to happen next, because we've looked at all the people in the past, and this is what they do if they behave like this. So this guy, he could drop off. He could, he may be a paying customer. So if you just prompt him with the right message at the right time, he may be willing to pay, move from free to pay. So data analysis, data prediction, and now, in fact, we are moving to the next stage, which is using data to develop new products for our users, which can even be monetized, right? For example, now in Naukri, like I said, 60 million resumes, we have a database of salaries, right? So can we, right now we're just a job search company. Now we're looking to provide, salary information to companies to help them figure out how much they should be paying their employees, because we have this data which we have collected over time from so many people. So we've just test marketing a product called Talent Pulse to give people a sense, companies a sense of where the talent is, where are they hiring from, where do their competitors hire from, what kind of salary should they be paying if they want good talent, etc., etc., etc. So now actually we are even moving to the next level, using the data to build new products which can be monetized, right? Pricing analytics in 99 acres. We now have, for example, society level data, and locality level data on how house prices have moved over the last few years, right? And this data is now very powerful. Now this data can be made available to whoever wants to sort of access it and use it for whatever reason. So there's a massive this is, I think, a new trend. It's not just with our company; it's with every internet company out there. So there are fintech companies who are using data to sort of figure out who to offer loans to, at what price to offer the loans at, and so on and so forth. There are many more variables which they're able to capture than regular sort of offline businesses. There are, you go to an Amazon, you go to a Flipkart, they're constantly sort of figuring out who you are, when you last came, what you like, and they prompt you with the right sort of recommendations. They give you discounts if you're a loyal customer, or if they want to entice you to buy more. So all this is now data driven, and it's being done by sophisticated algorithms at the back end. So the world is changing pretty rapidly, even for companies like ours. And of course, there's a lot more happening outside. Like Ravi said, the volume of data, the variety of data. It's data today is not just textual data. There's audio, there's video. There's so much you can do with audio. There's so much you can do with video, right? We all read about or heard about how companies and even countries are actually using sort of various tools at their disposal to sort of do various things. The velocity of data is increasing, right? There is so much data being created every minute. It's just unbelievable. Millions of videos are posted on YouTube every minute. Millions of chats, millions of WhatsApp messages, millions of Twitter tweets. There's so much data in each of them. Now, how do you process the data, get insights out of this data, and make it available to people, right? So in a manner which they can use then to grow their business. I think that's the name of the game. And that's what a lot of companies are investing behind. And people who start early will do well.
Thank you, Hitesh. Sebastian, so I'm going to switch gears here and go to one of your very old experiences, which was one as an astrophysicist. So we have a lot of counselor and principal friends here, and I'm sure astrophysics is one of those fields that if a student asks, okay, I want to do this, suddenly we are flipped. Okay, what sort of training would this student actually require to get where he wants to be? So can you give us an overview of especially how data was important in your experience as an astrophysicist and your journey after that?
Right. So thank you very much for having me here. A very interesting debate. So indeed, I graded a PhD since a very long time ago in astrophysics, and from day one of my research journey, I've been working on very large data sets. So even so, now for almost 10 years, I'm working in the internet industry. So after I left the academic environment, I still never have seen as much data as I've seen when I was working in astronomy. So essentially, my background is in physics and with a strong mathematical component. That obviously helped a lot. And what has been changing massively over the past 20 years is the ability to deal with lots of information at the same time. So it's not only about the mathematical models that we have been developing on the back end, it's also essentially the technical landscape that has been changing. Our ability to process extreme amount of information on a very short period of time that have been changing. And unfortunately for me, I've been through this path, the technological developments, first in academia, so first in astronomy. So we are trying to solve very complex questions around the formation of galaxies and how the universe is evolving, based on only one information that we can get, which is light. Because the only tool that we have as astronomers is light. So we are creating those massive telescopes on the ground or in satellites to collect light. That way we could process and use to better understand the universe of ours. So that's a fascinating topic, but extremely complex on the background. There's a lot of physics going on, and the advantage of having data and the advantage of having the ability to survey the entire universe at the same one is that we had statistics. So we had many different examples. If I want to see how a star is evolving with time, I have billions of stars I can look, and I can basically capture the evolution, because at the same time I've seen many stars that are in different stages of this evolution. So essentially that's the way we started tackling the problems in astronomy. So data science started to enter into my life probably at halfway, because we had this massive amount of data, and to solve those problems, realized very rapidly that we could use statistical models. Instead of focusing on one individual, we could focus on a sample or a very large sample of them, and starting to be able to process the information that we have to understand what is the journey that those galaxies and stars are going through. And the funny part is when I decided back in 2000, around early 2010s to leave. I was a professor at the university and decided to switch to a business environment. I brought this entire concept of knowledge with me to apply to basically businesses, as Hitesh just and Secretary just described before. It opened a new world in the internet where suddenly statistical modeling and ability to reproduce behavior of customers was possible as long as we had enough information for people. So when people, what we need to understand with data science, it's a game of numbers. We're not tracking, we're tracking individuals, but we derive behavioral patterns based on groups. So that's segmentations, we create groups, and there's basically statistics that is governing this on the back end. Yeah. So that's basically how I see it today. And beyond all the productivization of data that as we are doing today, making those recommendation engines or when I'm working today in a travel industry, it's been it's nice, interesting journey right now with everyone stops traveling. But anyway, nonetheless, when I'm asked my basically customers, which are corporate travelers essentially, so the business travelers, what they want, they just don't want to book anything. They just don't want to hear about travel. They just know that on that day they need to be somewhere, and for them, the ideal product we can develop for them is that they don't even have to think about it. Right? That's essentially the goal here, is that we completely outsource, even it's brainless. If you're an executive, you have a secretary, right? But if you're a normal business traveler, you don't have that. And essentially what you want is don't think about it. And that's essentially what we're trying to build. So we really develop those products to ease the life of our customers as much as possible. And the same goes with recommendations, that you don't have to think, you know immediately what you need next. Amazon has been working, for instance, in predicting what you're going to need next, that you don't even have to order it anymore. So that's essentially the type of things that we try to develop, and that requires for that a strong understanding of the technological background and also a statistical and mathematical modeling. So that's the path for data science. Data is everywhere. So in companies I'm working for, we also want everyone in the company to be able to back up any decision that they are making based on the data that is available. And that's a very powerful instrument. And I always say that I will trust the gut feeling of my CEO, because he have 20, 25, 30 years of experience in this industry. So he have gathered this extreme experience throughout his life to understand what's going on. I won't trust a very junior person about it. But the good news is that if we provide access data to everyone in the company in a way that they can use it, then they get access to this experience directly, because we can basically provide them the information that help them taking the best decision based on past, let's say, data acquisition, or on forecasting, or even on the numbers that are there. So I think for me, the biggest change that I see happening right now are twofold. The first one is these wonderful products and AI that we're talking about, but also is the fact that more and more people can use data on their daily life and in business life at least, and take the best decision out of it.
Okay, that's very interesting, and I think I'm going to come back to some of the points you mentioned, especially about the relevance of data across the board. But before I move on to the next set of questions, I'd urge the audience to also ask questions. Also, I have put up a poll, which you can see on the right-hand side of your screen. I can see that 10 people have already answered. The question is, do you think data is a core skill today? And I can see that 8 people have said yes, 1 has said no. If anyone else wants to vote, please go ahead. And that is the question that I'm also going to ask to our panelists. Professor Kothari, coming to you first, do you think data is a core skill today?
Oh, without a doubt. So I think that if you go across, any across areas, almost every area is being reshaped by data. So for example, let me give you a few examples. Take the legal profession. One of the big things about the legal profession is precedent, right? I mean, judgments are always based on if you can show that a similar thing invoked something, then that's a big basis for this judgment. What better thing than a machine to look at a situation and just search through everything that happened in the past? So in some sense, we are redefining how things are being done. Take medicine. Many of you might have heard that one of the biggest discoveries, this sort of the most potent antibiotic that has been discovered, was discovered about a few months ago, and it was discovered predominantly by using some machine learning algorithms. And so this whole concept of rational drug design, as it is called, has the ability to shrink discoveries of drugs from from its present 10 years, $1 billion, to taking a few months and maybe $1 million. Right? It makes things so much more accessible. I know that there was this competition in Russia in which an entry was submitted. So this is a literary competition, and and writers submit their entries in this competition. And one of the entries that got submitted last year and that made it to the top 10 was actually generated by a machine. Right. So that is the level at which data has started, influencing different areas. And I just want to take two examples of what data can do. And these are very rudimentary examples, but nonetheless, it will bring out what data can do. Let's say I'm traveling from here to the university. Now, and let's say you can observe me. Now, you can observe how I'm moving because somehow you can observe my cell coordinates. And I stopped at a particular place. Now, you don't know I stopped because of traffic, or I stopped because I just wanted to buy something, or run an errand, or something else in between. But take large amounts of data. Imagine that you observe everybody, right? And now, if everybody is stopped at a particular place, it is highly unlikely that they're all buying something in between. And now you can start averaging over things and know that, okay, there must be a traffic jam, right? And now you suddenly have the concept of Google Maps, and you start seeing the red lines and all the other types of things. So my point is, when you are able to instrument over large numbers, right? When I'm able to observe over large numbers, there is a lot of insight that you can get. Let me give you another very rudiment. I'm taking examples which are beyond the obvious examples. Let us say that I am responsible for the road condition in Delhi or in the national capital region. Right? I want to know every road where there is a pothole, and I want to repair it as soon as possible. Now, one way is I can have hundreds of people, running around, and trying to look at roads and seeing where there are potholes and all of that. If you actually invoke data science, here is what you can do. I can involve a simple sensor, right? And that sensor looks at the road surface. If the road surface is broken, it has a different reflection. If the road surface is solid, it has a different reflection. So it's a simple ultrasonic sensor. You can buy it for 25 rupees, in a hobby shop. I have lots of cars. I have all these Ola, Ubers running all around, and they go all over the city. Right? They go to every city, thousands and thousands of trips every single day. If I could install one of these sensors below a car, right, and all it does is as the car goes, it tells me whether the surface underneath the car is solid or not. And I start averaging over all these thousands and millions of trips that are happening, I now have a real-time idea of how my roads look. That is the power of data science. If you are able to instrument it, right, if you are able to get the data, then we have enough algorithms now to make problems very, very, solvable and very efficiently solvable. Okay. So whether you are now, the question is, are you in computer science? No, I'm a road, I'm a municipal corporation person, let's say, and I'm interested in knowing the road condition. Or I am a virologist and I am interested in designing a drug. Or I am a literary person, I write, I'm a lekhak of sorts, I want something to help me write creatively the next chapter, given all the previous chapters. Or I'm in the legal profession and I want to now, see that for this particular client case that I have, what is the precedent around it? Right? And in all of these cases, I can invoke data science. And so it is not dependent on a particular domain or a discipline or an outcome. I think data science is as important as reading and writing was in the previous generation. Right? And that's what. So to answer your question, definitely, I think it's a fundamental skill.
Thank you, and I think that summarized beautifully. And 86% of our people agree with you.
Then you go averaging over a large number of people, and we get wisdom out of it.
So Hitesh, rephrasing the question for you slightly, especially because I'm assuming because of Naukri.com, you have a great overview of how the job trends are evolving. How important do you think data is to career prospects, especially for people who would be, let's say, graduating sometime in the next 4 to 5 years?
So, there are, so one is, of course, the people who specialize in data scientists, as they're called, or data analysts, or, so there are a bunch of people who call themselves data scientists. They've studied data, they become expert at statistics, mathematics, algorithms, coding, they know machine learning, they're familiar with all the tools of the trade. So already we are seeing that such people are in short supply, and the demand for people like them is going through the roof, right? And we're already seeing that companies are willing to pay, companies, especially companies which have a lot of data, the platforms I mentioned, are willing to pay top dollar to hire these young professionals, right? So they are willing to pay even more than what they're willing to pay computer scientists. They're willing to pay them more than what they're willing to pay MBA graduates and so on and so forth already, because there's a dearth, there's a shortage of such people today in the market. Now, could this change? Of course, this could change going forward as more and more universities and colleges launch such programs, as more faculty is available, as more people start doing these courses. Of course, things could change. There was a shortage of, for example, Android developers and iPhone developers 10 years ago when these skill sets were new, and companies are willing to pay a premium for whoever sort of understood mobile development. And today, many more such people are available. Of course, the mobile revolution is still on, and there's a lot of demand for such people. But companies have figured things out, institutes have figured things out, and but today we are at a stage where it's still very early days, and there is a shortage of such people. So that's on the specialist side. Even on the regular side, today, like I said, it is data is available everywhere. Data has in the previous year, in the previous era, what used to happen is that very few people, there was not much data available. So you would run an ad campaign. Let's say if you're a Coke and you run a TV commercial, you collect data from the market a month after running the commercial, and then you know whether your commercial has worked or not. And even then, data is, it's fairly vague. And therefore, what used to happen is that the guy who was the most senior in the company, his opinion used to count the most, because he used to say, "Main market kya tha, mujhe pata hai, I know, I've been around for 20 years, so therefore listen to me," right? And that's how all the decisions were taken. But today, data is available in near real time. Right, so you can track demand, you can track sales, you can track if you're running an online platform, you run an ad, you know how many people came to your site, whether they bought stuff, whether they did not buy stuff, how much was your cost of acquisition. It's available almost in near real time to everybody, and therefore, one, it's important for companies to make it available to everybody if it's not available inside the company. So just let data, because it's there, it should be democratized, it should be available to everybody, and once you do that, it becomes easy for everyone to take decisions. And the person and hierarchy does not matter anymore, because, if you have the data and you can make your case, you will be heard, right? Even if you're the junior most person in the room. So what is beginning to happen is that companies are looking to hire people more and more who have an appreciation for data, right? Because unlike, 10 years ago, 20 years ago, there's a lot of data available. You can get insights from the data very quickly if you know how to deal with data. And therefore, it is important for students and working professionals to cultivate a data mindset, because that's what companies are going to increasingly look for. They're going to look for people who believe in data, who understand data, who appreciate data. They may not be the data scientists I spoke about earlier, they may not be data engineers, but they could be business guys or marketing guys or sales guys who are data driven in their head, right? So because data is available now, if data is available and you're not making use of it, you're being foolish, right? Earlier data was not available, therefore you had to do various things sort of to figure out stuff. But today, if data is available and you're not going to capitalize on it, you're missing out on an opportunity, and companies don't want to do that. So increasingly, I think data mindset, data culture, democratization of data, appreciation of data, I think these things are going to be sought after, and companies are going to would rather hire people who have these skills, and therefore if people have these skills, they will command a premium over people who don't have these skills in the job market going forward.
Thank you. So, Sebastian, I'm going to field Ms. Shalini's question to you. She's asked, can you probably comment on this general myth that a person has to be very strong in mathematics to be successful in data science? What do you have to say about that?
So, just to briefly, the access to data is lowering due to the level of access to data is lowering thanks to the technology today, right? So it's getting easier and easier to deal with data. And to just continue on the line of thoughts of Hitesh, I always like the example that before you need to be specialized to be a typewriter. You have years of specialization to know how to use a machine. Nowadays, it's a given that you know how to send an email. And no one will even ask you, and it won't be a bonus on your CV because you're able to send emails, right? People were specialized into that before. So that's the same way I will see the evolution with data. So to answer to the question, depends on what you want to do. But even in data science, I'm a data scientist myself. I consider such myself. And we see specialization also of this kind of people. So we have the all-rounders, the data scientists that have the mathematical background, or physics background like I do, that is able to code and understand what the business knowledge and the business domain is working in. But we're getting now also more and more specialized into the different kind of data science. There are also a very strong software engineering background that is nowadays needed to be able to bring those algorithms at scales in production that they can work automatically on their own. So it's software development essentially. So there's now a new breed of data scientists that we call machine learning engineer that needs to roughly understand those algorithms, but somehow are more specialized and bringing them into software that can be used in the products that you're using on a daily basis on your smartphone or through the internet, for instance. So you need, for data science particularly, you need to have a background in mathematics, but the strength will depend on which specialization you will take. If you get to people like me that are more focusing on the statistical modeling part, so really developing the algorithms that I use, for sure, you need to understand stats, you need to have a strong mathematical background. And just not because I am a physicist, but to my view, after a few years, people that have a background in physics are actually very well suited for that. For a simple reason is that they're not mathematicians. They're not interested in mathematics. They're using mathematics as a tool to solve complex problems. And that's what makes physics actually a very, very preferred stream for people to embrace data science. At least that was the case until recently, where we start to see more and more specialized training at universities on data science itself. So, yeah, in short, yes, you need to have a strong mathematical background, but what we're going to see more and more is a spread of specializations around data and data science that requires also people that come from more software engineering background to gain into that. So there are different routes you can take to enter that field. That said, you don't need you don't need a very strong mathematical background to use data on your daily basis. And that's also a nuance that we need to bring, is that data as a tool that everyone can use requires basics in mathematics, but I think the access to this knowledge is getting lower and lower and lower. And now we need to understand, of course, the concept of mean, average, and all those things. So basic statistics to use the data to take the right decisions. So it's different from what is the specialization of data science.
Thanks, Sebastian. Professor Ravi, I'd come to you, and you're probably the one here that interacts the most with students. You, as at Ashoka, and you're also involved with Plaksha's academics. So maybe could you give us a glimpse of what kind of students you see who generally perform well with data? Is it people just with a strong mathematics background, or is something else also required?
Right. So maybe maybe I can add a little bit to that question. So there are two types of data scientists in some sense. There are some people who are developing new algorithms in the area of data science, and new machine learning algorithms and new, NLP, natural language processing, and things like that. Obviously, for that group of people who are inventing new methods in data science, mathematics is an important uh, area, and a lot of the algorithms, etc., are based on or use mathematics. However, a large fraction of people are not inventing new algorithms. They are using existing algorithms to do whatever they are doing better or more efficiently. Right? And for that large group of people, they are also data scientists or data, people who use data science as a tool, and that does not necessarily require mathematics. So the analogy is almost that if I know how to drive a car, I don't need to understand combustion in order to reach from point A to point B. Right? But if I want to design a whole new car, of course, I must know what combustion is, right? I must know what thermodynamics is. But without knowing it, I can be as productive, get into a car and go from wherever I need to go to wherever, things of that nature. So that's the first part. The second part, and this is a very interesting one. So the machine learning courses that I teach, every year there has been an increase in the number of non-computer science people who take that course. Right? And it has been an amazing and a very insightful. So initially, there were people in economics, in mathematics, in biology who used to take that course. But of late, I've had people from philosophy take it. I've had people from English literature take it. Right? And that fraction has been increasing, steadily over time. And one of the interesting things, in fact, last year we sort of tried to understand why. One of the interesting things that happened was that the best performers in the class were not necessarily those who had a quantitative background. Right? In fact, the best performers in the class, one of them, is a dual major in philosophy and something else, and I have no idea where machine learning fit into that thing. Right? But nonetheless, I mean, it sort of brings out the fact that the original question, that I think at one level you're enhancing the field of data science, new algorithms. But the more interesting activity that is going on is people all around using data science to do whatever they are doing much more efficiently and benefiting all kinds of things. So
Okay.
um,
Um, People really like your examples, Professor. Okay, Hitesh, coming to you, and this might be the last question of the discussion. I know you have been a big proponent of interdisciplinary education, both at Ashoka as well as Plaksha. And I know you are also a supporter of the data science, business, and economics track that's coming up at Plaksha. Um, Especially with respect to business, there's this question of how to use data most effectively, which I'm assuming requires something more than just mathematics or an understanding of data. So, could you comment on some of those skills, could call it soft skills or peripheral skills that are required to make good use of data in business?
See what I'll tell you what we've seen in our company. The people see it's very hard to do something creative or new if you work in a silo,
Hmm.
right? So to build something, and we are all about building new things. We're all about creating new things. We're all about going from 0 to 1 in many cases, and from 1 to 100 in others, because we are trying to build products which don't exist today. See, if you're a superstar, if you're a Steve Jobs, it's fine. Maybe you can do anything. But if you're not a Steve Jobs, often you need to work in a team, right? So what are the kind of teams we have in our company? We often a team would comprise of a product manager who is either an engineer or a management graduate. You will have a UX designer. who understands design thinking, design, consumers. You will have engineers who can build code and stuff. You have, and you have data scientists now, right, as a part of that team, because they figure out how to sort of use the data which is available to us to improve the experience. Now, all these people need to work together as a team to create something, right? So, and when you're working in a team, stuff like how collaborative you are, right? How how well you communicate, how much of a team player you are, right? Do you put the team goals ahead of your personal goals, right? How good is your understanding of the domain? Because ultimately your solution will be applied. You want to solve a problem, right? So how good is your understanding of the customer? How good is your understanding of the market? How good is your understanding of the domain? How good is your understanding of the data we have, right? These things also become very, very important. Otherwise the risk you run is, if you work in a silo, you may build stuff or nobody else wants to use, right? And that happens often, especially with engineers, because they're good at building stuff, but they don't really sort of figure out whether somebody wants the stuff they're going to build, right? The people who are generally sort of what we've seen is people who are good customers, people who are good at understanding the market, they don't know how to build stuff, because they haven't been trained in engineering and so on. So they need the engineers to build stuff, right? So all these people need to work together to build something which sort of creates value for the company, for the customer, for everybody, right? And therefore an appreciation of all this, number one, strong communication skills, teamwork, collaboration, creative thinking, curiosity to understand what's happening out there, what's available, what is possible today which was not possible earlier. Some of these things start to matter a lot as well, and that's why the focus on interdisciplinary education, both within engineering at Plaksha. So today, for example, and maybe it's not enough if you're just a computer engineer, because if you want to build a drone, you need communication technology, you need computer science, you need mechanical engineering, you need various other things. So you need to work with other engineers as well, number one. And two, you need even more sort of stuff like leadership skills, more stuff like, a more liberal arts stuff also thrown into your education, so that you are able to sort of work well with other people, right? Which is where a lot of engineers fail after sort of, a few years. So that's the idea behind Plaksha. That was, in some ways, even Ashoka is trying to sort of do the same thing. They're approaching it more from a liberal arts standpoint, and they're now putting science and, computer science into that curriculum. So I think that's the future, and institutions which understand this, and students who acquire, who sort of more well-rounded and more sort of holistic in their thinking, I think will, in the long run, do better than others.
Okay, thank you so much. With that, we come to the end of our discussion. We have with us educators who are effectively going to nurture the next generation of creators, and it's been a pleasure having all of you for this conversation. Thank you again, Professor Kothari, Hitesh, and Sebastian, for joining. Have a good evening.